Hello everyone, welcome back to my YouTube channel. My name is Gunashri R, pursuing my third semester BE in Electronics and Communication at Sri Venkateshwara College of Engineering. Today I will be talking about the subject Digital System Design using Verilog, and the subject code is BEC 302 and my topic is Subtractors. First, let us see what is an half subtractor. Half subtractor is a combinational circuit that performs the binary subtraction of 2-bit binary numbers, because of which we get the two outputs, difference and borrow output. Here in the diagram, we can see A and B are the inputs and difference and borrow are the two outputs. Now let us see the truth table for half subtractor. Since there are two inputs A and B, so there will be four possibilities, that is 0, 0, 0, 1, 1, 0 and 1, 1. So the outputs will be difference and borrow. When we give the input for A as 0 and B as 0, so the difference will be 0 and as well as borrow. It's because 0 minus 0 is 0. When we give the input to A as 0 and B as 1, the difference will be 1 and borrow will be 1, because 0 minus 1 is 1 and there would be a borrow. When we give A is 1 and B is 0, so 1 minus 0 is 1. So the difference will be 1 and borrow will be 0. When both the inputs are 1, so 1 minus 1 would be 0. So both the difference and borrow outputs would be 0. Now let us take the truth table as reference and implement a K-map to get the Boolean expressions. So the difference output is 1 in 0 and 1 and also in 1 comma 0. So we are going to take this both in outputs and put it in the K-map to get the Boolean expression. So when there is 0, 1, 1 and 0 in the K-map, we'll get the expression as A bar B plus A B bar, which can also be said as A XOR with B. For the borrow output, it is 1 when the combination is 0, 1. In the K-map, we are going to take it as 0, 1 and 0, 0. Since there is only one input, so the equation would be A bar dot with B. So the Boolean expressions are difference equation is A bar B plus AB bar or A XOR with B. And for the borrow expression would be A bar B. Using the previous Boolean expressions, let us implement a logic circuit for the half subtractor. So this is the logic circuit for the half subtractor, where the difference is A bar B plus AB bar or A XOR with B, and the borrow expression is A bar B. So this is the logic circuit of the half subtractor. As we can see, this A XOR with B is implemented using XOR gate. And to generate the A bar dot B signal, this A is inverted using the NOT gate, and then the output is given to this AND gate. Next, that means the output of this AND gate is equal to A bar dot B. So in this way, we can design this logic circuit half subtractor. Now let us see the advantages of half subtractor. Half subtractor circuits are very simple and easy to design, implement and debug compared to other binary arithmetic circuits. They are simple combinational circuits with only two inputs and two outputs, so the simplicity makes them easy to design, implement and understand. They are the basic building blocks that can be used to construct more complex arithmetic circuits such as full adders and subtractors, multiple bit adders and subtractors, and carry look ahead adders. These circuits use only a few gates, which reduces the cost and power consumption compared to more complex circuits. They also can be easily integrated with other digital circuits and systems. The application of half subtractors is very wide. They are used in calculators, alarms, automotive, security, and computer frameworks. They are also used to do arithmetic logic unit processors used for basic subtraction operations. In the calculators, they are employed in mini computers for numerical calculations. In the alarm systems, they are utilized to compare input signals and trigger alarms if differences are detected. They are also used in audio and radio systems, which is used to reduce signal strength or compensate for distortion. Now coming to the disadvantages of half subtractor. Half subtractors can only perform binary subtraction of 2-bit single-bit numbers respectively and are not suitable for more complex arithmetic operations. For multi-bit numbers, multiple half subtractors need to be cascaded, which increases the complexity and decreases the efficiency of the circuit. The propagation delay of the half subtractor is highly compared to other arithmetic circuits, which can affect the overall performance of the system. Now let us see what is a full subtractor. The full subtractor is also a combinational circuit that performs a subtraction of three input bits, namely A, B and Bn. There are two outputs, namely difference and borrow. As shown in the diagram, we can see A, B, Bin are the three inputs given to the full subtractor, and difference and borrow are the two outputs given to the full subtractor. Now let us analyze the truth table for the full subtractor. Since there are three inputs A, B and Bin, so there will be 8 possible combinations, and D and B out are the two outputs. When all the three inputs are 0, the difference and borrow output will be 0. When A and B are 0 and B in is 1, so 0 minus 0 is 0, so 0 minus 1 is 1 with a carry. So the difference will be 1 and borrow also will be 1. In the third combination, when the A is 0, B is 1 and Bin is 0, so 0 minus 1 is 1 with a carry. Also 1 minus 0 is 1 with a carry. So even here the difference and borrow outputs are 1. In the next combination, when A is given 0 and B is given 1 and B is given 1, so 0 minus 1 is 1 and 1 minus 1 is 0 with the carry. So the difference will be 0 whereas the borrow will be 1. In the next combination, the A is given 1, B is also given 0 and B is given 0. So 1 minus 0 is 1 and as well as again 1 minus 0 is 1. So the difference output will be 1 whereas the borrow is 0. In the next combination, A is given 1, B is given 0 and B is given 1. So 1 minus 0 is 1 and 1 minus 1 is 0. So both difference and borrow become 0. Next, A is given 1 and B is also given 1. Bn is given 0. So 1 minus 1 is 0. So 0 minus 0 is 0. So both difference and borrow are 0. In the last combination, all three inputs are given 1. So 1 minus 1 is 0. 0 minus 1 is 1 with a carry. So difference and borrow will be 1. Now by taking the inputs from the truth table, we can implement the K-map for full subtractor. So since for the first difference equation, we have to take the inputs where difference is 1. So that would be 0, 1, 0, 1, 1, 0, 1, 0 in the 8 cell K-map. So the difference equation will be A bar B bar B in plus A bar B B in bar plus AB bar B in bar plus AB B in. Now, by taking B in common in the first two terms, we can write it as B in of A bar B bar plus AB plus again taking the B in common, B in bar of A B bar plus A bar B. Now we can write the given term as B in A XOR B plus B in bar of A XOR B. In the next step, we can write that as B in of A XOR B whole bar plus B in bar of A XOR B. In the next step, B in A XOR of A XOR B. So finally, we get the output as A XOR B XOR BIN for the difference. Now coming to the borrow, the K-map implementation is as shown. Now for the equations, borrow is equals to A bar B bar B in plus A bar B B in bar plus A bar B B in plus AB B in. In the next step, we can write it as B is equals to A bar B bar B in plus A bar B B in bar plus A bar B B in plus A bar B B in plus A bar B B in plus A bar B B in. And finally, we get the borrow equation as A bar B in plus A bar B plus B B in. Now let us see the logic circuit for a full subtractor for both the equations difference and borrow. For the difference, the A and B inputs are connected to a XOR gate, whereas its output and B input is connected as inputs for another XOR gate. We get the difference output. Now this is the logic circuit for the borrow. Here A and B are inputs which are connected to a XOR gate, which is in turn connected to a NOT gate and given as a one input for the AND gate. And the other input for AND gate is given from the B. And for the second combination, A and B are taken as the inputs for another AND gate where A is given NOT gate. Now both the AND gate inputs are given as inputs for another NOR gate. So B out is the output. Now let us see the advantages of full subtractor. The designing of full subtractor is very simple as well as to implement and to design. It enables subtractor of multi-bit binary numbers. It also handles borrow propagation efficiently, ensuring only accurate results. It is used in various digital circuits like ALUs, microprocessors, digital signal processor, and other digital systems that require binary subtractor. Now coming to the disadvantages of full subtractor. Full subtractors are specially designed for arithmetic operations so they cannot handle decimal or other number systems. While cascading multiple subtractors, the time it takes for a signal to pass through the circuit can limit the speed of operations. For larger numbers, these full subtractors can increase circuit complexity and more power consumption. They are not suitable for other arithmetic operations like addition and multiplication as they excel in performing subtraction. So these are the information about half subtractor and full subtractor. Thank you for watching.